record this. Is it recording? Do you see the little? Yeah. Okay. Cool. So hi everyone. My name is Jairo. This is the Let's Code workshop for the AI SIG. It's called the Data Cleaning and Visualization with Python, Pandas, and Seaborn. Because of the time constraints, I'm actually just going to focus on the data cleaning. If you have any questions about visualization and Seaborn, please feel free to message me. We can have a one-on-one with me. Or if you want just the resources that I know, I can just send it to you. Feel free to message me on my Discord. Let's go to the next one. Again, my name is Jairo Carreon. My interests are the NBA and data science. My position in ACM is I'm the vice president as well as the co-lead for AI SIG. And a fun fact about myself is that I collect Pokemon cards. With me, I have our watch. I forgot to put you in this thing, but you can just introduce yourself.
Oh yeah, that's no problem, Jairo. So hey guys, I'm Bharadwaj. You may remember me from the SIG AI Let's Talk events, but here Jairo is here um, giving us the Let's Code event. It's going to be really interesting. Yeah, and I am the co-SIG lead as well with Jairo. Yeah, Jairo, take it away, man.
Cool. So now this workshop is going to be separated in 3 parts. It's going to be preparation, setting up, and explaining data cleaning, execution using pandas to clean different types of dirty data. And my goal is to bring data science awareness to UC Merced. We don't have a data science major here, but as you know from last workshop, it's all about statistics, math, computer science, and the other part, NPL, Barwich, do you remember?
NLP.
NLP. There you go. So with that said, our preparation, again, please open your Anaconda and open your Jupyter Lab within Anaconda. Anaconda is a navigator and Jupyter Lab is an environment. But if you have any other environment that you like using, feel free to do so. There's Google Colabs, Kaggle, Visual Studios, and other ones that are, they're sufficient. You can use them. However, my favorite ones, my favorite navigator is Anaconda, and my favorite environment is Jupyter Lab. And PyCharm. PyCharm. Uh, I haven't used PyCharm, but what do you think, Parwatch? You can use PyCharm?
Yeah, I think we're good. Yep.
Okay, yeah, you can use PyCharm. Yeah, that's fine. Cool. All right. So with that said, now there's a link on the Discord where my GitHub is at, and there's gonna be a repo there. I think I put it in the chat, but I think I had to paste it again. Jet, you did it. Okay, cool. You can do it again. Go there, download or clone the repository, and just if you actually let me show you. Let me change my screen so I can show everything. So as you can see, let's go over here to my GitHub. Where's my GitHub? To my GitHub, just go over here. You can either copy here, go to your terminal, go get clone, and paste this link, or you can go to download zip. You download the zip, right? You're gonna save file. You're gonna open it, and you're gonna export it. And once you export it, just put it on your desktop, so it's easier to access. Okay, back with the workshop over here. Now, with that said, the first thing I want to talk about is a little exercise that we're gonna have. So this workshop is about data cleaning. But what does that mean? What does data, like clean data, look like? What does dirty data look like? What does messy data look like? What does clean data look like? What does that mean, right? So with that said, I have an exercise with you. I have 2 tables right here. I have table 1 and table 2. Table 1 has an index of names. It has 2 columns, which are treatment A and treatment B. This is for like a doctor, right? So I'm a doctor. These are my patients. These are the treatments that I've given them, and these are the results, right? And I have table 2, which has treatment A and treatment B as my index, and the names of my patients as the columns as well as the values of the results within the table. So please just put it in the chat, just put one or two and let me know what you think. Which one is better? Which ones would you use? Oh, which one do you like, right? Let's see, table one, table one. All right, for sure, table one, one. All right, for sure. So you all like table one, and it just like the actual answer is like it just depends on what who you're asking, right? It just depends, right? And whatever you're using. If I'm a doctor, I want to know what John Smith is taking, right? It's taking treatment A, it's taking treatment B, and I want to see the results, right? I want to input those results real fast, right? If I'm writing it on a piece of paper, I feel like this would be the faster way, right? But the actual faster way for us in our, Pandas environment, Python environment, in our us coding is actually table three. So table three takes all the our index and makes it into a new column called name. They take all of our columns, right, for table one, so treatment A and treatment B, it makes them values, right? So we take all those column value, all those columns, put them in an actual just one column, and we call a new, we make a new column called treatment, and we have our own specific column for our results, right? However, if I'm a doctor, this will be harder for me, right, to look through, right? So I go, John Smith is taking treatment A and has no results. And I had to scroll down, scroll down, scroll down. I missed it again. And right here, John Smith, treatment B, result has a two as a result, right? So it's harder for me to look through the data. However, over here it's easier. But for us coding, kind of just messing around with data, this is way faster. This is basically the basics of clean data, right? Clean data consists of three things: tidy data. So consider three elements. One is each variable forms a column, as you can see, a variable name, a variable treatment, a variable result, right? These are values. Treatment B, treatment A, there's two different values. They're not variables. Treatment is a variable, but treatment A is a value. Each type of, oh, we can see, each type of observational unit forms a table. That means, for example, I have a data set of where I was born, right? I was born in San Diego, in this hospital, at this time. It was sunny outside, whatever, right? We have that data set. And we have another observational unit that is where I'm living right now, right? I live in Merced. It has my address. It has how many people live here, how big is my house. Two observational units, right? They're both related because of me. However, having them together in one table and one data set wouldn't make any sense. They don't relate to each other. Why would I have to know the hospital name when if I, why would I have to know the hospital name in the same table where I know my current address or my current how many people live in my house, right? It just wouldn't make any sense. It would be super messy. And the last concept would be each observation forms a row. As you can see, an observation, I'm observing that John Smith took treatment A and had no result. And over here, I'm observing that Jane Doe took treatment B and had 11 as a result, right? These are all the values that we can observe. However, over here, I can only observe the results, and only results don't have any meaning if we don't know from who they are or from what treatment they are, right? So it's just easier for us to use this in a method, like in a statistical model. Like let's say our Y component is our result and our S component is our treatment. This will make it way easier. And now what's messy data? Messy data is comprised of five things. First, column headers are values, not variables, right? So as you can see, this treatment A and treatment B are values. They're not variables. They're not column variables, right? They're values, and that's why we put them right here inside our column. A, B are all values. So that's why table one is dirty or it's, messy data. Now, multiple variables are stored in one column. That's basically saying if we have a column of names, we wouldn't want to put a number in there, right? So if I have Jairo, Bararo, Chet, Denny, Paulo, Alex, we wouldn't want to put 101. Like that wouldn't make any sense, right? Like it would be like, why the hell is that there? Now, for our third concept is variables are stored in both rows and columns. That's just basically saying we wouldn't want a a treatment column and a treatment row. Because while we repeat ourselves, it kind of just intersects and it wouldn't make any sense, right? We have a column called treatment or we have a row called treatment, but not both. And now our fourth one will be multiple types of observational units are stored in the same table. Like I said before, we don't want a data set of where I was born and a data set of where I'm currently living in the same table. We wouldn't want that because it would be messy. And now with the last one, a single observational unit is stored in multiple tables. That means data set where I was born, we don't want it with the data set where I'm currently living, and I don't want the data set where I was born into my data set of my favorite ice cream, right? We don't want that, right? Because it's just messy. It's a lot of things that just keep repeating itself, right? We rather connect them with the NID or some type of stuff like that we can actually use. So if you took databases, you know what I'm talking about, right? So now let's move on to execution. With this said, you can open your Anaconda environment, Anaconda Navigator, go to your Anaconda Navigator and launch it. Jupyter, Jupyter Live. Just launch it, open it, and once you're there, it's gonna look something like this. Right here is it's all your files or your folders. So, like I said, put the zip file after you abstract it in your desktop, or if you cloned it, please just move it to your desktop so it's easier for us to access. Go to your desktop and go find Data Cleaning AI SIG workshop. That's the folder. After that, just go right here to notebooks and we're gonna go to the intro version. So it's basically I'm gonna introduce Pandas and Python Studio, and I'm gonna be using the intro blank. Oh, it's not blank anymore. What the hell? I don't know what happened here. But let's say this was blank. Um, so the intro blank, it was supposed to be just all clear so I can write on it. And the intro is all there for you. So if you want to type it down, you can just follow along, right? So with that, let's just get started. Either just follow along or if you want to type with me, feel free to do so, right? If you have any questions, just put it in the chat. I'll make sure to look at that like once in a while. But our first thing is gonna be importing pandas. How do we do that? We just say import pandas as PD. Pandas is a library for data manipulation, right? And as PD is basically saying PD equals pandas. It's just gonna simplify our code. It's gonna look nicer because imagine writing pandas 100 times and imagine writing PD 100 times. It's easier to mess up a 5-letter word than a 2-letter word, right? So it's gonna be easier for us in the long term. And it's gonna save us time. So our second thing to do is we're gonna create a data frame, right? And we're gonna create a data frame with the data in our file gapminder.tsp. You can open it up. The cool thing about Jupyter Lab is that it shows like this, like an Excel sheet. It's kind of cute. And it tells you the delimiter, which is a tab, which that's going to be a problem right now. So we're going to create a data frame. We're going to create a variable called df for data frame. We're going to call pandas as PD. So PD dot read c CSB underscore CSB. That's a function of pandas, which is gonna give us permission, basically permission for us to use the data inside this .csv file. We're gonna input the one of the parameters that we have to input is the path. For me is dot data slash dot slash data slash the name of the file, which is gapminder.tsv. And because it's a TSV, which is tab separated values, instead of a CSV, which is comma separated values, we have to specify that, right? So we're gonna call the parameter sep. In quote, we're gonna write backslash t. And if I did that correctly, if I shift enter actually, so you have to shift enter each cell. So shift enter this, shift enter this, shift enter this. That's how you compile it. That's the faster way to compile it. And now you can just click this play button right here. So after you shift enter and there's no errors, so I did that correctly. So now we want to see the data. As you can see, I already did it before. So it's going to be df. You can just type it down. It's going to be df. Or you can use the dot head function from pandas, and it's going to output the first 5 rows of your data set, right? So it's going to be from 0 to 4. Cool stuff. But what about if you just want to know all the column names, right? So as you can see, I already did it before. It has country, continent, year, life expectancy, right? It's all over here. It's all over here. What if I just want to know the column name, right? We can just write an attribute of the data frame, which is columns. Boom. What if I just want to know the index? I can just type down df, call the data frame, and write index. That's gonna basically tell me, hey, I start at 0. There's 1,704 rows, and the step is 1. So it goes by one by one. So 0, 1, 2, 3, instead of going 0, 5, 10, it's gonna go one by one. Now, what if I just want to know the values? We write down the data frame, and we're gonna dot, and just write values after that. So df dot values. This is just a NumPy array. If you work with NumPy, this is how data actually looks. You know, I better like what's it called? I rather see the data like this because it's easy to visualize it. But if you're working with NumPy, this is how it looks, right? Now, let's see what type it is. What type of data frame are we working with? So we would do by typing the function type, and inside there we will input the df, which is our data frame, and that would say pandas.core.frame.data frame. That makes sense, right? Because we're using pandas in order to create this data frame. Now, what shape is our data frame? We will know that by using the attribute.df.shape. Right, we have 1704 rows and 6 columns, right? And I just want to emphasize that this is an attribute. These are attributes. Because before, when I was learning pandas and Python, I used to write this like this, and I always got confused, or like, why is it giving an error? That makes no sense, right? Why is it giving me an error? It's just because this is an attribute, and this will output that, but this is a function, and that doesn't work with the data frame, right? So I just want to emphasize that there's attributes, there's methods, and there's functions. Right now, I want to know what data frame information, the data frame information. We can do that by calling the data frame df.info, and it's a function, so we'll put parentheses, and it's going to give you all the information that we did before. So for example, it's going to give you the type, right? The type of the data frame. It's going to tell you how many entries it has, from what index, from 0 to 1703, the number of columns, the name of the columns, the index, if we have any missing values. So for every single one of our columns, we don't have any missing values. As we can see, we have none null, and the data type that the column is taking. So for country, it's taking an object, which is most likely a string, and for year, it's actually taking an int 64, right? And how much memory it has? It takes is 80.0 uh, kilobytes. Now we want a specific column, right? What so a column from the data frame? I think there's as we can see, I might just choose country, right? So I might just call the data. I might just print out all the country column values. So I might write down df, and in brackets I might write down inside the brackets I'm gonna put a string with the name of the column that I want. So the name of the column that I want is country, and if I just shift enter that, it's gonna output all the country names in the column country, right? So it's gonna go from 0 to 1703. It has Afghanistan, it has Zimbabwe, and many others within this, right? But what about if I just don't wanna write this over and over again? I can just make it equal to a variable, right? I'm gonna call it country, and I'll call it bar, right? With that, I can just copy paste this. Oops. I can just copy paste this over here, shift enter, and then country var. I can just write it down again. And as you can see, it's the same thing. But for me, this is way easier to write. You can even call it something even simpler like C, right? Just one letter word. Oh, it's not defined. What did I not define it? Oh, did I do it before? There you go. Boom. Same thing, right? Now let's create a subset. Damn, I didn't delete this. All right. So we create a subset, a variable subset, and we made it equal to the data frame, right? And I wanted a country, the continent, and a year columns, right? I wanted all of those. But instead of writing it like this, I put two double brackets in order to signify that there's a list of things that I wanna of the names of the columns, right? So we have within the list, we have country, continent, and year. And after we compile this and we write it down, we have that our subset equals the country, the continent, and the year columns with all of its values. Now, now, do you know what version of Pandas you're using? I know which one it is because it's right here. But if you don't know how to do it, you just have to write down PD dot. This is another attribute of Pandas, which is underscore underscore version underscore underscore. We shift enter that, and it's gonna tell you what version of Pandas you're using. So let's say you don't know what the problem is. You copy something from Stack Overflow, and you don't know what the problem is, right? Maybe you have the wrong version of Pandas, and maybe you have to update it to the recent version of Pandas, right? Or maybe someone's using the previous version of Pandas, and you have the latest version of Pandas, and it's not gonna work, right? So make sure to check that once in a while, you know. But now we want to know what the data at index 2. How can we do that? So as you can see right here, we call the data frame, and we use a method called .log. This .log is basically saying locate in the data frame row 2. Simple as that, right? Locate in the data frame row 2. And after you compile, it's going to give you all the information from the column names to the values within that column. It's also going to give you the name or whatever row you inputted, and the object it takes, and the object it is. So the data type it is. So it's an object. So now we want data at index 2 and 0. In order to do that, we're going to do the same thing all over again. So it's going to call the data frame df dot log, and in double brackets, we're gonna write down what we want. We want row 2 and we want row 0. So it's gonna be 2 comma 0. And as you can see, this outputted a table of rows 2 and row 0 with all of its columns and all its values. So that's really simple. If you wanted to know, maybe you wanted the 100th row, just simple as that. Just put a list in there and of the row values, the index values that you want. But now we move to more subsets, right? Now, all indexes, but only the year and the population column. How do we do that? First, I create a new data frame, which is going to call it subset, or a new subset. I'll call it subset underscore 2. And I want to make it equal to our data frame, df, and then I'm going to use the method dot lock. And inside there, I'm going to put two things. I'm going to put this colon. This column basically signifies that it's all true, that we want all of the indexes. And after that, I'm going to write a comma and a list of the columns that we want. In this case, we want the column year and the column pop. So we write that down inside the list. We use the column in order to signify that we want all the indexes, the location to locate all of this, the dot log to locate all of this, and the df just to know where we're getting all of that, all the data. After that, you shift enter, and it's going to give you this table right here, this data set right here. It looks all nice and simple. It's going to just have the year with all of its year values. It's going to go the population with all the population values. Now, what if we want the column, the column year and pop, and also we only want the year, the value, the rows with the value 1967 in our column year? Simple enough. You can just copy and paste this if you're running with me. Put it over here. We're gonna write df because of the data frame dot log in order to locate these specific values, and then at the end it's gonna have the the columns that we want. So it's gonna be year, comma pop inside brackets because that's a list. But before the comma, we had to write a Boolean statement saying, hey, when this is true, I'll put that row. So when the data frame, when the column value, in the data frame, the column year value in this data frame equals 1967, up when that equals true, then I'll put that row with a specific column. So as you can see, all of our years have 1967 in them. But now let's go to our next one and our last one of this summary of Python and Pandas. We want the columns year and pop. We only want, again, 1967. Only the years with 1967 in it. But now we want the population to have more than 1 million. And that's easy enough. You can just copy and paste this over here. I'm gonna just do it. Copy and paste. And we already answered this question right here. The column year and pop, we already have that one. We already have the 1967. But now we just have to add the next Boolean statement before this comma right here. We're gonna do an and parentheses just to make it cleaner. And I'm gonna say df pop more than 1 million. Pandas is nice enough for us to give us like permission to use underscore instead of commas, because it's kind of confusing when you have 6 zeros here. It's kind of confusing to look at it, but we can do underscore and it won't affect the number. So now we have this new Boolean statement saying inside this column, when it's more than 1 million, when that's true, and this other statement is true, output those values, those rows and the specific columns. After you do that, you shift enter that, and you will have a new table with just the year 1967 and just the populations with more than 1 million. And with that, it's just the first half of the workshop. It's just a review of Pandas and Python. So if you're still here, please go back to your notebook. As you can see, I'm right here in the folder Data Cleaning AI State Workshop. So go back to the notebooks folder inside there, and you can open up either Tidy, which is already done for you. So if you just want to follow along, you can do that. But you can also use the Tidy Copy 1, which has all of the nothing in it, and I'll be writing it for you. So you can just follow along with me. Let me just clear all the outputs so I don't know what's happening. And let me move to my notes over here. And if you have any questions or anything, just let me know. If something didn't work, just let me know. I know the path is kind of confusing at times. Sometimes it works, sometimes it doesn't work. Yeah, but just let me know. Let me know in the chat, or just unmute yourself.
I have a question.
What's up?
Can we change the shape of the data with pandas?
Yeah, we actually can, and I'll show it to you right now in this part over here. We'll use actually like two functions. One is called melt, and the other one, I'm kind of losing it right now, but I'll show it to you. The other one's called merge. Yeah, so I'll let you know. Any other question? Okay, so with that, I'll move on to the next one. Please open the Tidy Copy 1 if you want to type with me. But if not, if you just want to follow along, just open up the tidy.ipynb file inside the notebook folder. So let's open this up. The first thing it says is to import pandas. So that's what we're going to do. We're going to import pandas as PD, shift enter, and we're going to also import our data, our Pew data. So if you go to the data folder, it's going to be right here. You're going to open it. You can see it. It's cool. We're going to call it Pew. We're going to call this data frame Pew. And we're going to use pandas pd dot read underscore csv. And we're going to give it a path inside here again. It's going to be within quotes. It's going to be dot dot slash data slash pew dot csv. And we had to say that I separated by commas because we don't have to, right? Because this is a CSV function and this is a CSV file. So we're gonna shift enter that, and now we want to see it. If you want to see the data, you can do pew dot head, and head is a function again. As you can see, this is nice. Religion, it tells you all the religions there is, or the religion of the people they survey. But however, they tell you, however, this looks messy right here. This looks messy. It's supposed to be in religion, income, and like count data set. However, how we have this data set doesn't really like say that. So we're going to change it right now with the function melt. So in order to do that, so I'm going to say melt in the first place. Melt basically gets this wide data set and just makes it long. It just makes it super long. So in this case, we have all this right here that we're gonna make it into a column, just one column, and all of these values would be in its own separate column called results, right? So if you didn't understand that, I'll show you right now. So first, we're gonna make a new data frame. We're gonna call it pew long, and we're gonna make it equal to pandas dot melt, and we're gonna input our original data frame, which is pew, and we're gonna say id bars equal religion. So this id bars parameter is basically saying, hey, don't mess with this column, right? Because this one is fine. This column religion is fine. However, these other ones, we want to melt them. So this, apart from the religion column, do not mess with the other ones, right? So mess with the other ones, but the religion column. So if we shift enter that cell and we write down pew long and shift enter, as you can see, we changed the data frame, right? We changed the data set from this long one, I mean this wide one, to this long one. But now, as a default, uh, all the column names that we made into values, they go into a column name variable, and all the values, like all these ones right here, all of these ones, go into a column name value. But for me, in this data set, that doesn't have any context, right? Doesn't make sense. If someone looks at this and like, what's the variable and what's the value? So we do the same process, but with actual significant column names. So in order to do that, we copy that cell, paste it over here, and we put another parameter in there, which one is called bar underscore name equal income, and the other one it's value name equal count. We shift enter to make sure there's no errors, and this parameter is basically saying just change the name of this, and this value name is going to change it to count. So this value name right here is going to be count now. And if we want to see it, shift enter. This is way better looking. This has actual context to what we were looking at. Not like before where you saw religion, it has a bunch of numbers, it has money. Like what does that mean? Does that mean like how many like 10K donations they get? Does that mean how many 10K like marathons they do, Like what does that mean? But now we know what it is. We have in the I'm gonna say the Catholic religion, the income and the people who we count. It could be people count. Actually, people count. So we have 418 other people who were surveyed that were Catholic, made less than 10K a year. Now, that's how the melt function works. But now I'm gonna just give you more examples of how it works as well. So now we're gonna use real data or billboard. So I'm gonna call this data frame bill, if I know how to spell it, billboard equal pd dot read read csv, and inside, like I said before, we put the path to that to this file. So inside this file, it's it's in data, it's in the folder data, and it's called billboard.csv. We shift enter, didn't give us any errors, so that's good. And I can just write down again billboard, shift enter, and this is the data frame that we have, right? So it has the year, the artist, so it has Tupac, Zombie Nation, Three Doors Down. It has the track name, Baby Don't Cry, Another 9 minutes, time of the song, the date entered to this data frame, and it has the week one rating, the week two rating, the week three rating, the week four rating, and so on, so on, so on until we get to week 76. So as you can see, this is messy. It has a lot of columns. That could be just that there are actually values, right? So week one is the value of, let's say, we're gonna call it like week. So we have a column named week, and a value of that column will be like week one, week two, week three, week four, week five, right? So this is messy, and we didn't even know what these numbers are, right? We don't even know what they mean. I know because I looked at the data, it's actual ratings, but here, someone that just barely seen this data frame wouldn't know. So we gotta change that. So in order to do that, we're gonna melt it again with the function .melt. I'm gonna call it billboard melt, and I make it equal to pandas, which is pd, and I'm gonna call the function melt. Inside here, I'm gonna call our original data frame, which is a billboard, in order to melt it, billboard, and then I'm gonna have the ID bars, which again is the list of the columns that we don't want to mess with, right? The list of columns we don't want to mess with. In this case, is the year, the artist, the track, the time, the data entered. Everything else, we want to melt it. So I don't want to write this down. I'm just gonna go to the one that I already finished and actually just copy and paste it. You can do so if you type in with me. Let's see, copy and paste that. And we're gonna do comma. From there, again, we're gonna, since this melt function is gonna give us a default column name of variable and value, we just wanna change that to something that we can understand. So a variable column name would be week, and then our value, our result column would be rating. So value underscore, what was it? Name equal rating. We shift enter. Hopefully there's not. Okay, cool. There's no errors. We copy paste the name of the new data frame. Shift enter that. As you can see, now instead of having 76 columns of from week 1 to week 76, we just have one that's called week. And see, in week 1, Tupac had a rating of 87. In week 1, Three Doors Down, Kryptonite, the song, had a rating of 81. Three Doors Down had another song that around that same time It's called loser. Has had a in week one, same thing, 76, right? So that's maybe don't crack. Yeah, it does. It does. So that's super awesome, right? So now we want to compare the dimensions of both the original data set and now our new data set, our Billboard data set and our Billboard Melt data set. In order to do that, like we did in the first half, we're gonna call it, we're gonna call Billboard dot shape, an attribute of pandas, and we're gonna go shift enter. Our original billboard had 317 rows and only in 81 columns. But now what if I want to call billboard melt and I want to know the shape of that, right? So what's the result of us melting this? That is this. We're gonna have 24,092 rows and 7 columns. And that's a significant amount, right? That's a lot of data. That's 24,000 times uh times more. I don't know, like 10, 100 times more than that. I don't know, 10 times more than that. So that's a lot, right? And that's because we still have to clean it up more, right? We still have to clean it up, and I'll show you why. So in this, all rows with the song loser. All right, so we can do that. We're gonna call our new data frame billboard. I'll show you why we still have to clean it up. Billboard, billboard underscore melt. Did I spell melt right? Yeah, cool. And in that, we're gonna be using the method dot lock. And inside the method, we just want to know, like, we want to put in boolean statement saying I want all the rows with the song loser, right? So it'll be again bill damn. Oh, there you go. Billboard melt, and to know the song loser, that's inside the column name track. So that's what we're gonna do within those brackets. And we're gonna say a boolean statement saying if it's equal to loser. So it's saying locate in the data frame billboard melt whenever the the value in the column track inside the billboard melt data frame equal to loser. So if we shift enter this, nice. There's no error, so that's good. And you're gonna see that all the tracks are named loser, right? But they're all the same. The only difference is the week, right? The only difference is the week number and the rating. But everything else is the same data. And we don't want that, right? Because in the beginning I said that there's like two different types of observational units. Like like I said, you don't want to put the information of me, where I was born, who was there, what hospital, into like the data set of what are my favorite ice cream places, right? We don't want to put that, even though they're connected to each other. We don't want to put them in the same table because it's going to be messy. So we're going to connect them. I don't know if it's two databases. Like I said, that's what we learned there. So in order to do that, I'm going to store the songs info into the data frame. I'm going to make a new data frame called billboard songs, and that's going to be equal to billboard melt, because that's our second data frame that we're going to be using. And inside there, we're going to list all the columns that we want, which are going to be the year, the artist, the track, the time, and the date entered. And again, I want to type it down. So I'm just going to copy it from before. Control paste. Shift enter. There's no error. Let me see. Oh, triple brackets. There you go. So now we can look at it. Billable songs dot head, which will show us our first 5 rows and our columns. And look at that. Now we will have 2 different unit observational units. We only have the song information, and now we're gonna later create a week and rating data frame. So let's move on. If you want to see the shape of this, billboard songs dot shape is still 24,000 and 5 columns because we reduced it, right? We took out this too. Now, make sure not to have duplicates, right? Like I said, this thing has a bunch of the same songs, same song information, and we just moved it into this billboard song. So we just took out the 2 columns where we didn't take out the duplicates. So in order to do that, we have to we'll make the billboard song, the billboard songs data frame equal to itself, but using the function, the pandas function, drop, say drop underscore duplicates. That's the function. And then we'll go shift enter. And if you want to see it, if you want to see the shape of it, as you saw before, the shape was 24,000 rows, but now it's 317. So that's basically saying we have 317 rows of unique songs, right? Of unique information. With that, we'll move on. Like I said before, if you took data structures, we had to connect different data frames together. So in order to do that, we're gonna create a data frame called B ratings for billboard ratings. So let's do that. So first, I'm gonna create an ID in the billboard songs because the index is something different than an ID, right? So billboard songs, and I'm gonna create a new column and I'm gonna call it ID in order to identify different songs, right? And I'll make it equal to this is okay, so it's gonna be the range, the length of billboard underscore songs. So I'm just gonna compile it. Why did it give me an error? I misspelled something. Billboard range length billboard songs. Do you guys see the error somewhere? Might as well just go copy and paste it from where I finished it. Where's it at? Boom. Oh wait, did I call it billboards? Yeah. Let's copy and paste that. Then I still have the error. What's up? See the cabinet is the documentation. If someone sees the error, let me know. Let me know what's up. Songs ID equal range parentheses length billboard songs. Well, I don't want to waste time in that. So let's go over here where it's all finished and all nicely done. So we do this And after it's supposed to work, I don't know what happens. That just happens sometimes, and you just gotta look through it. But after you do that, after you do the range, the lane, and the billboard, basically it's gonna make this column have a unique ID from 0 to the end of the length, right? So it's gonna be 217 unique IDs. From there, we can actually create our own CSV file by using this function called .to underscore CSV. But put it in whatever name you want. So I'll call it billboard songs underscore songs.csv and put in an index equal to false. If you run this, which I don't want to run it because I don't want to go through any errors again, um, it will show up over here. It will show up in here. I don't want to run it. Yeah. So it will show up over there as a billboard underscore song.csv. So if you work with data and you have like a data frame that you're really proud of and you really just want to have it in a file, you can just do this function and it's going to look nice, right? And now we create a new data frame called billboard ratings. In this data frame, we're going to melt. We're going to use the billboard melt and we're going to merge it. So this is, so we're going to be merging, basically saying where these columns are equal, when all the values are equal, and that, then just add the rest. What does that mean, right? So our billboard melt underscore melt used to look like, it looks like this. It has a year, an artist, the track, the time, the data entered, and all of that information, right? And our billboard songs looks like this. Has the year, the artist, the track, the time, and an ID. Now, we want to know where it's equal to each other, right? So we have the year, we have the artist, don't move that, artist, track, time, right? So we just compare it. We compare where the billboard and the billboard songs meet, and we'll add wherever is left. So in this case, it's going to be our new column named ID. So after you run this and you paste it and do .head function, we have a new data set which has an ID over here. Where can I get the file? What file are you talking about? David? The Python file? Oh, all of this? Is that what you're talking about? If you go to the Discord, yeah, okay, yeah. If you go to the Discord, in AI SIG, you'll have my repo there. If not, someone can paste it in here. I don't think I have it. I don't have it with me right now. But if you stay a little bit longer, I'll just paste it, and you can go there. You can just copy my repo, either download it or clone it into your machine. There you go, Paulo. Thank you. From here, again, after merging it, after finding out where those two data frames connect, we'll create another billboard ratings. But now we only want the ID, the data entered, the week, and the rating, right? Because that's what billboard ratings info is about. We don't want to know the name of the song. We don't want to know what was the artist. We just want to know what the rating was, when it was, and when it was entered. With that, we're gonna make it to another CSV file using the .to underscore CSV. We give it a nice name. We put it index equal to false. And just like that, you would have another CSV file right here, but I don't want to compile it because it's probably going to give me an error right now. And that's the end. We'll just check out the information for all of our data frames. So billboard underscore ratings, it looks like this. It has 4 columns. It has 24,091 Oh, yeah, this was the early stage. It shouldn't have that many. No, it's supposed to have that many. Yeah, it's 74 weeks times the amount of songs. It should be 24,000, right? It it tells you right here that we don't have any missing values. However, in ratings, we do, right? We do have a lot of missing values. Actually, it's like a significant amount, but that's fine because when a song releases, it gets the rating in the first let's say 10 weeks, and after like the 10th week, you wouldn't have a rating unless you're like, you know, Little Nas X, right? Now we go to the next one. We check out the information from the Billboard songs data set. Same thing, index from 0 to 316, total columns is 5. It's not missing any values. It takes this columns take an object and this columns take the int. And int 64 and this one takes an int 32. And the last one, billboard underscore melt, takes in 24,000. And the same information is right there. That's pretty much it. That's the end of the workshop. I'm a poster on the YouTube channel. But if you have any questions about the Seaborn library or how to do visualizing and stuff like that, please feel free to message me on the Discord. I'm the vice president. It just says Jairo Carreon, vice president. Just text me there or put it on the AI channel, and I just put all the resources there. You can also go to the repo that I have right here, and it has some links right here, like where the article where all these ideas came from, because I didn't make it up. This is actually from research. I can show it to you. It's actually from research that I read, but however, this is in R Studios instead of Python. So after like a while, you're gonna stumble R, and I honestly don't like R, so I didn't want to. I want to make an R workshop. I wanted to make a Python workshop, and yeah, and then it's gonna have the Pandas API if you want to learn more about Pandas, and then I'm gonna push something right now so you can have the Seaborn link, so you can actually look at all the Seaborn functions. So if you have any questions about that, just let me know. Text me on the Discord, and with that, I'm done. I'm gonna stop recording, and if you have any questions, just please, we can do it right now.